All right. So we're going to talk about Unix and Linux. We're going to talk about OS design. And we're going to talk about abstraction. And then we're going to talk about composability. And maybe we're going to talk about these things. So let's see. We have things. Things in general will be represented by cubes. So this could be a much more Socratic thing, but I think I'm gonna plow through it. We can make it pretty later. Okay. But I'm gonna go straight to the point, more or less. But the tangents that could be made about this are very, very interesting and elucidating, so I should make another version. So, okay. So, I say that in the world there are things, right? So, an animal is a thing, and cars are things. Everything is a thing, right? Planet is a thing. The universe, sure. Okay. And then I say that there is another thing that is an arrow. So an arrow here is, so this is our first abstraction, because we're saying we're going to use a cube from now on to represent any one thing, right? So a cube can be a beach ball, or a cube can be a pencil, right? Or a cube can be a cube, right? But this represents any one thing that we might want to talk about. So this is a representation. This is our first abstraction. So that means we're going to use the cube to mean anything that we might be talking about when we use the cube, right? So the cube acquires meaning when it gets inside of a context, right? Okay. And there's the arrow as well. So what are arrows? So arrows are our second abstraction, and arrows represent something that things, as we just defined, right? So this is a thing. Things are they are things, but they are not actions, and an arrow is an action. So this is something doing something, right? Now remember, let's remember when you give me a box, right? And then I erase this, right? I don't have a black eraser, so. And then I have the box now, right? And you have a hole on the page. So this happens, right? And this is an action. So an action, you gave me a box, right? That's one action. Now, but remember that we weren't going to represent it in this style, because I actually I have to change the drawing, right? So we're not going to do that. So I want to represent what happened by not changing anything. So this is how I'm going to do it. I'm going to select this. I'm going to copy it. And And then I am going to make a change. And here, yeah, I don't know how to change the pencil size, and I don't really like this interface. I don't want to mess with it. Alright, so remember, now what I want to do, instead of changing a drawing, I want to represent an action with all of the spots where something changes, right? So anyone that comes in the room, anyone can understand what happened, what I did, or what I explained, or what we were talking about, right? So you and I are both watching this. We saw the progression, right? But if someone comes in your room right now, and if they see this, they can understand what we're talking about, because all of the changes are explicit, right? All of them that are important. They're important to us. Whereas by drawing over something, someone that comes in your room wouldn't understand what happened, because all they would see would be this drawing, right? In the end, if I'm drawing, over and over the same drawing, and I'm modifying it and I'm changing that drawing, right? Then all that person would see when they come in is this. So they wouldn't understand that you had the box first. They would think, oh, Peter had the box all along. Okay, so this is more explicit. But notice then, do it in red, that now the arrow is this, right? Because before it used to be this. So the arrow before was an action, because it pointed to something that changes the world, right? So that's why the arrow was an action. So we're talking about things that exist in the world. So there are things and there are arrows, right? So an arrow in the world, in the real world, an arrow is like an action. But we don't want an arrow like that, because we think that this is more useful. It's more useful to represent changes by snapshots, okay? So we've decided that, taking a snapshot of each point in time where, right before a change occurs, right? Or right after, right? But you get the important points of, so you don't get like a bunch of, similar pictures, right? A bunch of pictures that are actually the same, so you get like the different ones. So we're taking a snapshot each time something interesting occurs. So this is the arrow that we want in our world, right? So we don't want to model exactly how the world does this, because then we don't want to change, remember? So we don't want to change. So instead we're going to change, instead we're going to choose this other arrow. This arrow here has a different meaning. So that arrow before, where I drew over, and then I actually erased this box, and then I drew a new box, but I kept the arrow, right? That arrow was an action, because it represents something that changes over time. Now this arrow does not represent something that changes over time, right? Because all the information is at once there. So what does this arrow represent? It's not an action anymore, because remember, we want to define action here to mean something that changes, that takes place in the real world, and that changes the state of the world. So, but this arrow does not represent something that changes the world. So the arrow before that I drew represented you giving me the box. So that arrow represented an action, because you giving me the box changes the world, right? Because it starts from a world where you have the box, and then it goes to a world where I have the box. But in the world that I have the box, you, with the box, you don't exist like that anymore. So things were changed. But we don't want that world. We want a world of pictures, of photographs. So we want to take snapshots, and we want to say, listen, this happened, and this is the arrow. So before, it was like this, and now it's like this. this arrow is more generic than time. We don't really have to say now and before. We don't have to say those words because this arrow represents exactly what it's pointing to and what it's pointing from. It really represents that this image has a relationship to this image, right? And then we can say, and that relationship in this case is of change, right? Then we can say that. So we can specify the arrow. But in general, the arrow is simply pointing to two drawings. It's pointing from one drawing to another drawing, right? So it's saying there's a relationship between them. And in this case, it's a relationship of change. Because look, I can draw another arrow that is not of change. Let's see, 3. And then a square of size 3. Okay. So this arrow says there's a relationship between the number 3 and a square of side 3. And there is, right? The relationship being that the square's side is the same size as the number. So this is one arrow that is not an action, and it's not change. It's just a relationship. Because the 3 didn't change into a square, right? They belong to different worlds. A 3 is a number, natural, and the square is a shape, right? So they don't belong in the same group. They're not of the same type, right? Don't belong in the same category. Okay. So that's why this arrow, I want to look beyond the fact that in this case, when we're talking about this, it represents, yes, it represents change. But that's because we agree that this is a box, and even though that the box is on the other side or whatever, right? We have an explanation for this, right? We say, you gave me the box. That's what happened. And not, the paper you were holding fell to the right onto my hand. So we agree on what it is, and that's why the arrow here in this case is a change, right? Because we assigned a meaning, we assigned the meaning that if something changes hands, then that means, the person that was holding it is giving it to the other person that is now holding it. Okay. So the arrow is more general than action. So the arrow is relationship, right? I'm not gonna draw it in. I'll write it rather. Relationship. So that's what I am saying, that the world can be divided in two things that are important to us as programmers. Okay, so this is an alternate way to model reality, but to capture what we're actually focused on. It's a different focus. So in object orientation, the world is divided as objects. So in object orientation, if you have a dice or a die, right? It's like 5, it's 3 here, and 1. Sure, that may be consistent. Yeah. Okay. And the die, or the dice, I'm gonna call it dice. The dice has a method. The dice is an object, right? And it has a method throw. And so that's how object orientation chooses to model the world. It says, okay, when I throw a dice, what I'm doing is I'm sending the dice the message throw. This is a classic OO from Smalltalk. The corrupted OO brought from C++ or in Friends has a different way of seeing this. It says that now what you do is object knows how to throw itself, and I can invoke throw, its throw method. I can invoke it, and so method invocation is a different way of doing OO. That was originally through message passing messages to objects, right? That essence was captured by Erlang. People don't consider it an object-oriented language, but the essence is exactly what Alan Kay was talking about when he was talking about message passing, I believe. Okay, so throw can be modeled in different ways, even when you choose to model the world as object orientation, right? So you can look at it in different ways, and they're all called object oriented, right? But usually we're gonna differentiate between OO classic, which is Smalltalk, and OO C++ corrupted, right? And so this is how object orientation chooses to model reality. It says, okay, there are these objects, and somehow they understand how to do these things. And when I throw a dice, I am saying, dice, throw. And I say that with my hand as I throw it, right? That's what it means. That's how the object orientation is capturing it, the essence of change. It's saying, oh, the objects have state. They have states. So the dice is either showing a 1, or it's showing a 2, or it's showing a 3, right? It's totally not like that, but whatever. So the dice can be showing different faces. So it has that state. That's how object orientation models it. And it says, then you can call a method on it, you can send it a message, and you can tell it to change its state. So, you know, if I pass the dice the message throw, then what it does is it throws itself, and then it will randomly pick a face to show, and that will be its new state. The new state will be the face it's showing. Okay, that's what's important to us, right? Because no one looks at on the other faces. We could model that too, but it's not important, right? Because when you're throwing dice for a game, you care about the face on top usually. But that's not how we're choosing to model things. So let's erase this, right? Because that is not how we're choosing to see the world. It's not through objects. I was just drawing it here for comparison. So we don't want objects. Nope. And we decided we don't want objects because things we can't see the change very well when we change the picture that we're drawing on. So when we change the state, we can't see what happened very well. So we chose we don't want that. So we have this new arrow that means relationship. And the relationship arrow and the thing together will be our tools in modeling the world. So there are no objects, so you see, so we're starting off more abstract. So object orientation says there are objects and then there are actions. And that's what a method represents, and message passing is saying, you know, is provoking an action to happen. So in object orientation, we can say that it uses objects, and it uses methods. But I'm gonna call them messages. Okay. So their object is messages. but we're choosing to see it as things in relationships. So remember, we abstract thing from object, so a thing can be anything, right? Anything you want. And an object models anything in the world as an object. And a relationship is like an action, but more abstract, right? How is it abstract? It's abstract because an action, as we saw, it was that other arrow. That was the action. And an action actually happens. That's what an action is, right? We have to be careful in our terms. So an action is really something that happens in the real world. That is what an action is. And object orientation chooses to model the real world by changing the machine, just like the real world would change, right? So object orientation makes a program that actually changes, actually happens. So the object-oriented program actually happens through time, just like actions do. So it literally uses actions. And then it literally uses objects in that those objects are places in memory. They're slots. They're memory cells, right? And it changes them, literally. So the memory cell at one point can be holding the number 8, and at some other point can be holding the string hello. So it literally changed. So object orientation is a literal view of the world, because the world indeed has objects and actions, and or you can choose to see actions as messages, depending on if you look at causality as more important than sequentiality, right? But it has objects and actions. That's how the world is. And so object orientation got it 100% right, in that it does use the world. And it does model the world perfectly, right? Because the world indeed has objects and messages. It indeed has objects and actions. It does. And in object orientation, you actually have those things, those exact same things. So your objects are objects because they're memory cells, and they're actions because they literally exert change on other objects. So they cause other objects to change. So they are literally actions. So they are literally this arrow, this green arrow. That's what a message is, but I'm not going to draw it as an arrow. I'm drawing it as this weird thing, right? Okay, so we don't want this arrow. So let's erase it, because I don't like it there. Because we don't want this. This is so hard to understand, right? Because you're drawing over your changes and you don't know what happened. Okay. Pick another color. Okay. And so we're gonna choose to do things with things in relationships. So I have belabored this point enough, I believe. And so I want to clarify then how a thing is more abstract than an object. It's because an object is one thing. So remember, a class, right? Usually in an object-oriented language, a class is the blueprint. So it's the blueprint for how to build the object, right? So it's gonna have an initializer, and then a machine will go and make sure that this state is 0. This other state is 5, and this other state is HALLO, and then that's what a class is. There's like the instruction plans for how to build an object. So you call the method new on the class. By example here, I'm using Ruby, and the class then builds you a new object and it gives it to you. So now you have an object. And this object is a literal object in the real world, right? You have to understand this, because it is in the memory on a computer, right? and it can be changed. So it is an object that exists in the real world. So this is not an abstraction. That's what I mean, right? It's not an abstraction because it is a literal object. So it's not modeling the real world. It is part of the real world. So this object is what object means here. That's the object, the real object. But a thing is a representation of something. So this is not a real object, right? I want a thing to mean anything. That's how I defined it. Remember. So it's all objects. So a thing is all objects. That's what a thing is. So it's kind of the opposite, because an object in object orientation is one object. That's one, right? So you make one and you get it, and then here you have it in your hand. That's the one object you got. So if you say boat, not new, right? You get one boat and you go, yay, okay? But that's like one boat in real life, right? So you get one boat. When I say in real life, doesn't mean that it's the boat that goes on the water. But this is one boat because it was named boat, right? And you get one that, you know, occupies some space in the real world, and it can be changed because it could be destroyed, right? So it does exist. So you get a real boat in the real world. So an object is a real thing, but a thing is all things. So an object is one thing, right? An object is like one boat. You get one boat. There you go. You get a data, right? Structure that is a boat. And you get it. That's it. That's one. So that's what an object is. An object is like, for instance, it could be like a boat is an object. That's what I mean. A boat is an object. But a boat, sure, a boat is a thing, okay? But a thing is a boat. That's how I'm defining thing. But an object is not a boat. An object is what a boat is. Now, a thing, I want to mean all things. I want to mean anything. Any one thing. The difference is subtle, but it's important, because a thing, I can choose this cube to stand in place for anything I'm talking about. So it's a generic cube. It's a generic cube. But it does specify something. It specifies what it means, right? And what does it mean? It means any one thing. Because we've specified it, right? So I'm not saying that the word thing means that. I'm saying we're defining these terms, all of these terms, right? Objects have been defined somewhere else. Alan Kay defined it, right? And messages were defined somewhere else. Alan Kay defined it, right? But now we're defining other things because that's how we're modeling the world now. Not through objects, but through things and relationships. And those are the abstractions that we're choosing. So we're choosing to see the world this way. So instead of saying there's each one thing in the world, I'm going to say that there's a way to talk about one thing. There's a general way of talking about any one thing that we pick. We pick this one thing and we can talk about it. And so I'm saying that there's a concept of a thing that is being referred to. And so a thing doesn't change. Because let's say, when we're talking about a thing, let's talk about pens, right? Because I have a pen in my hand, a stylus. Let's talk about styluses, right? So I have a stylus in my hand. And so this is a stylus. And if I buy another stylus, then I'll have like two styluses, right? And so that's how I'm going to choose to talk about stylus. I'm just going to draw cubes instead, right? I'm going to draw this cube. So this is stylus, and I have three stylus, right? Three styluses. However you choose to do the plural. It's not styli. Okay. So if I have 3 styluses, then I can talk about it in this way. I can use any drawing for it. So I use the cube, right? So that's my thing. So I say I have 3 things, and so three pens, right? 3 styluses. So each pen is a thing. And that's why I drew 3 things for each pen. And this is probably how, you know, the first people learned to count, right? Because you can associate pebbles with the things you're seeing. Let's say, you know, animals, right? And you go, oh, there are different animals, and small rat. So there are 3 animals. So now you can use these pebbles and tell a story about the animals, for instance, right? You can represent the animals with pebbles, right? Now, but that's a very abstract way, because the pebble here, like if we're pretending that that's how people learn to count, then the pebble here is the invention of the thing. Because then you're using the pebble to say, you know, let's pretend that these are animals, and then now we're talking about animals, but the pebbles will represent animals. But the pebbles never change, do you see? Because the pebbles are still the same. Because the pebbles, they really, you know, what does a pebble do, right? Nothing. It does nothing. It just stands there. It's like a, you know, it's a small rock, and it just sits there. And boy, you can watch it, man. It's not gonna do anything. So that's the nature of pebbles, right? So it doesn't change, but we can talk about changes happening to them. How? By drawing arrows, right? So if we say, well, then this elephant went here, then we put another pebble here. Now this is another elephant, right? It's the same one, right? Because I'm saying, you know, this moved, right? So that's what I'm representing. That's the story I'm representing. I'm saying, I'm going to talk about when I saw an elephant and a tiger and a mouse at the same time, and then the elephant went this way, walked this way. So, but remember, we're not going to use objects, so I'm not going to move the pebble. I'm going to put a new one here. I'm going to put a new pebble here. And I'm going to say that this arrow means that the elephant walked. So this arrow is called a walk. And even though in the explanation these, you know, these pebbles represent the same elephant, right? But here, of course, in the real world, there are different pebbles. Why? Because in the real world, this pebble has a position, X and Y and Z in the real world. And this other pebble has another position that is X, Y, and Z in the real world. X prime, Y prime, Z prime. So it's a different X and Y and Z for this pebble. Even though we're talking about it as if it's the same, because it's representing the same elephant, right? So if you, okay, so I'm going to try and make some space here. So tough. Yeah, I wish I had more tabs or canvases, different ones to operate on. Okay, so I don't want to be drawing this small, you know. Okay, let's just make some space here. I'll just kill this. Or what we're gonna do is, well, actually, you know what I'm gonna do. I'm going to scale this. There we go. Put it in the corner. Then we're gonna paint the whole thing black. I know I'm such an amateur, but that's fine. I've accepted that. I'm not using abstractions here at all. But you know, I just got this, so I'll pick up. So we were saying that so if we look at an elephant, sure, and then a tiger, right? So a tiger. And a mouse, right? And we're saying we have 3 pebbles here. And what I'm going to do is I'm going to draw an arrow, and then I'm going to put another pebble here, right? Another one. And I'm going to say that this pebble represents, so now let's pay attention to the colors now. So I'm saying that this pebble represents the elephant, right? And this other pebble also represents the elephant. Okay. I'm not going to draw the one that represents the mouse and the one that represents the tiger. It's not important. You know, each one represents each. You can pick one, okay? But these are the ones because it's going to get complex over here. And I'm going to start drawing more arrows. And the arrows are now more important, right? Because I'm talking about arrows. But I'm using pebbles, you know, because they're all, they combine with each other. They're not useful in isolation. That's why I need both. Okay. And this arrow walk, so if the elephant walked like, you know, maybe it went that way. So I'm not going to really draw this, right? Why? Because this is the real world. So the real world, in fact, I should reverse the arrow, right? And then erase the other one, so thanks. Alright. So you see, so the arrow is pointing this way. So this is like, and this is a drawing of an action. So an action happened, and you know, an action happened. So the elephant was over there, and now it's over here. So I'm explaining to you, the viewer or the listener, I'm explaining to you what happened with pebbles, and pebbles are standing for things here. So I'm explaining what happened, and I'm saying the elephant was here, and then it went over there. So I'm saying with pebbles, I'm like, okay, so it was here, and then I put another pebble, so there are 4 pebbles on the board now. And then I draw an arrow, like with chalk or with a pen, right? In this case, a pen. I'm using a pen. And so I draw the arrow, and then I put another pebble here. So you see, you're seeing all the pebbles at the same time. You're seeing all 4, and then you see the arrow as well, right? So whereas in this drawing, so that's why I said I'm not really drawing this. I'm just drawing this to show you that this happened in the real world, and then I'm modeling it. But because this happened, I don't want to draw it, because then you're going to think, oh, there are 2 elephants. No. So this is not in the drawing. I'm just saying it's just a reminder. It's just a reminder that this happened in the real world. So I really saw this happen, right? But I didn't. I'm lying. But that's the story that I'm using to explain this abstraction, right? So I'm pretending that I actually saw this. So I saw this happen, and then the elephant walked. So it walked. So it's not the fact that there were 2 elephants and an arrow, so I can't draw it. So this is like how I remember it, right? So I remember an action taking place like la 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 la, and then it happened, right? So I'm explaining this through pebbles to show how we can see more here, right? So we cannot see this elephant, okay? So we cannot see this elephant in the drawing. It's just here to help you and I, the viewer, you, the viewer, and I, to talk about this. But this is not in the drawing for the purposes of the drawing. The purpose of the drawing is like in a frame like this, right? So it does not care about that, right? So that's the drawing. That's the actual drawing that I drew here on this screen, right? So here's how this is a better way to represent it, because then now you can see everything. So you can see where the elephant was, and you can see where the elephant is as I'm telling the story, right? And then I can say, oh, and then the elephant went even further, right? And right, you get the point. I'm not going to do this, but you get the point. So I can keep on telling the story, and you can always look at the whole story and see exactly what's going on. So at the end, you can ask questions by looking at it, and you can see an inconsistency, right? Maybe. So you can see, oh, but how did the elephant go from here to here, right? Because, you know, but usually you won't have that problem. Why? Because if you build it slowly and you put arrows, right? And as we're talking, I'm building this, then you're not going to let me put an arrow like this, because it doesn't point from anything or to anything. So you're not going to let me do this, right? So this is impossible, right? So this is not a problem that will happen. But you can notice other inconsistencies. Like, oh, this elephant over here, how did it get to be red, right? And then you can say, oh, because remember this arrow means that the elephant walked here and then a bunch of red paint fell on it. And then you go, oh, okay, now I understand why the elephant here is red. That's how it got to be red. Oh, because then you told me, oh, so in the story, oh, wow, so that's what happened then? So the elephant walked here, and then it was painted red. Yeah, yes, and you say yes, okay. And I go, oh, wow, that's so cool, right? Or you go, because I'm telling you the story. So you say, but I have to say, the arrow, remember the arrow means that it walked and then it was painted red by an accident or something, right? Or on purpose, right? For the story. But then I assign a meaning to the arrow. So arrows can take on different meanings. Like this pink arrow means that I am using this pebble to talk about an elephant. So that's what this arrow means. It means convert to real. If you want to be explicit, right? If you want to be explicit, this arrow means convert to real world. And this arrow means walked. Well, okay. It means walked and was painted blue. But we don't want to be talking about the past, you know. We want to have some consistency here. So we want to say walk and paint blue. I'm sorry, paint red. I'm using paint here to mean like be painted or whatever, right? But just the fact that the verb is there is what is important. So walk and paint red. That's the name of this arrow. And this other arrow means convert to real world. So those are like two good examples of arrows, right? So again, I'm choosing to model the real world in terms of things and arrows, and I'm giving you like a concrete example that arrows are useful, because I can explain to you how possibly how cavemen, right, learn to count or learn these abstractions. Like I'm saying, maybe they learned it through pebbles. And you go, well, how? How do they learn it through pebbles? How? I don't understand. And then I say, well, here's how. And then I use these arrows to explain to you how I think that they learned abstraction. And learned counting, which is the same thing. But not important. Not important right now. How a number is a general abstraction, and to count is to find all of the things in that abstraction. We'll get there. Okay. So here's a concrete proof that arrows actually exist in the real world, because they allow explanations, right? At least we know that they allow explanations. So they allow communication. So arrows in the real world, like these arrows are in the real world, right? They allow communication. And this is proof, like what just happened. I explained to you something. Now, we know, so these arrows can be anything that happened, but the arrow is not making it happen. So convert to real world doesn't actually convert a pebble to the real world. And walk and paint red, right? And I'm not saying because it's impossible. Like walk and paint red. This is not walking and being painted red. Like not before your eyes. Like I only do this once. I do this once, and then this arrow still means this, right? Why? Because it represents something that occurred in real life. So this orange arrow is related to this arrow that doesn't. It's not really in the drawing, but it's just there to help us, right? And so here's the thing, like this is an actual abstraction, right? Because it's talking about the real world, but it's not actually making it happen. It's not making it happen. So I put a pebble here that I painted red, but that's not changing the board, because the whole board is the explanation. So it's just the fact that I'm not done, right? So in the end, I'll be done, and then that'll be it. And then I could explain it again. So that's the proof that I'm not changing the board, is that when the whole board is done, I can go through the whole explanation again if I want to another person, right? And I don't have to build the board again, right? So if I don't have to build it again, then I was just changing it in quotation marks, you know. I was just changing it in the sense that I was putting new things as I was explaining, right, and drawing new things. But that's just because those things are not drawn yet. So I'm just drawing as I go along. But I could have these slides done, right? I could have this done, and I could say, listen, you know, here's how I could start this all over again and explain to someone, you know, that comes into your room again, someone new, and then I could explain, I was talking about pebbles, and you know, I think that the cavemen, that they first started counting, or they first you know, found out about abstraction by using pebbles to tell stories, right? And so I was saying how you know, an elephant that walked in was painted red, blah blah blah, and so I can explain all of this, right? I can explain all of this, and not have to draw it again. So I'm just changing it here, because I'm drawing as I go along, because I don't want to have this material prepared, because this is all improvised, right? But for the explanation, it does not change, right? So again, like, you can just look at it, it does not change. It does nothing, right? There's an arrow called walk and paint red, but this is not happening. Like, it already happened. And indeed, it happened here. This is where it happened, right? It happened here, when it actually happened. But I just want to talk about it now, so I don't want to make it happen, right? So I could if you have like pebbles of different colors, right? I could pick a pebble that is already red to explain that the pebble, you know, just to help, right? The pebble doesn't even need to be red. This is just to help, really. But the important thing is that well, actually, the pebble needs to be red, I think. Yeah, it does. But I don't have to have painted it, right? I could pick one that is already red to represent this, right? And to explain. Okay. And so these things didn't happen here. So this is an abstraction, right? This is an abstraction. Why? Because of everything that I just said, right? That's why. So this is an abstraction. This is not happening. It's removed from reality in the sense that these are not objects. Sure, they're pebbles in that, you know, they're objects in that they're pebbles, but in the story that I'm telling, these are not pebbles. These are like these different animals. And this arrow is not like ink pen on a screen, right? It's not pixels. This arrow is the fact that the elephant walked and was painted red. And this is not a pebble that is red. This is the elephant after it walked and was painted red. Right? So this is an abstraction. And nothing changes. Nothing changes, right? But I can still model reality. So this is a different way to model reality that is not using objects that actually change in reality. This is a different way. It's a different way. So I have pebbles, I have things and arrows, right? Right? Okay, so hopefully this concept is clear by now. Let's start talking about things a bit more instead of just arrows, right? So why is it that I can use pebbles to represent different animals? They're different animals, right? Shouldn't I have to use like you know, something else that is not a pebble, like a leaf, and then a stick to mean the tiger or whatever, right? But a pebble here is standing for thing. So anything, it represents anything, right? So you could use a different pebble, because remember, I was associating the definition of the concept of a thing, any one thing, to a cube. Now we could have picked, let's say, a triangle. We could have picked a triangle to represent any one thing. But we cannot have these two things at once. We cannot have these two things. We have to pick one. We have to pick one thing to represent a thing. Because if you have two things, then you start asking, well, how are they different? And that's not what we want to model in this abstraction layer, right? We don't want to talk about that. We want to talk about objects in general, about any one thing. So any one thing, and then we use any drawing. So I picked a cube. It could have been something else. It could have been a triangle, right? But it could not. I cannot be drawing triangles and cubes, together in the same example. I can make an example using just triangles, and I can make an example using just cubes, right? But I cannot mix them up. Why? Because that's how I divided things. That's how I defined one thing. So that's a thing. So let's start to be more specific here. So there's a type called thing. And everything exists in that type. Everything. So like this literal, wavy line is a thing, right? And now I'm gonna draw like a pyramid here to represent the 3 pyramids in Egypt, right? The famous ones, right? The Great Pyramids, right? And I'm gonna draw this one to represent all of them, and because I want to say that the pyramids are also things. They're also in the category of things. And what else? Well, the stylus that I'm using right now to draw is a thing. And several other things are things. All of them, really. But I'm not gonna list all of them. So this is enough. So everything is a thing. And by that, I mean, now we're going to get more specific. By that, I mean that we're going to define that there's a type. There's a thing called type. And a thing is a type. And it's a type that all things are of that type. So a wavy line on the screen is of type thing. So mathematically we say, we can actually squeeze this again. How do we do this now? No, actually we can just... So let's talk about types. Oh my, this is counterintuitive. Okay. Okay. Actually, that's not okay. Oh no. Want this over here. Over here. All right. So there's a type called thing. And this is its name, right? The type called thing has everything. It has the pyramids, has beach balls, and it has dice. So everything is of type thing. So if a beach ball is of type thing, then we say that a beach ball is of type thing. And if a dice or a die is of type thing, then we say that a dice or a die is of type thing. And if the pyramids are of type thing, and they are, then we say that the pyramids are of type thing. That's how we're gonna say it. That's how we're gonna say it on the screen. Now, everything is of type thing. So this type it's useful to start with, right? That's a good way. So instead of objects, we have things, right? And this is the difference, right? Because this is one object, right? That's one object. But this is what thing is. Thing is a type that includes everything. Or you can say that everything, every object in the world is of type thing. Every object in the world is of type thing. So we still look at the objects, but we don't consider the object to be the level of abstraction. Because why? Because it's not abstract enough, right? We consider the whole, what everything has in common. What is it that everything has in common? Everything has in common. So what is it that everything? So what everything has in common is that everything is a thing by definition. So our abstraction is like really basic. So an object, each object is a very complex, potentially very complex thing. And the concept of an object includes methods and classes and instantiation, right? It has all that story. But a thing, and it has all that mechanism, has all that baggage. So that's the concept of an object, is that whole baggage, right? That whole factory that is the mechanism that the object-oriented runtime uses. So the object-oriented runtime, it provides meaning to the abstractions that you use in object orientation. So the meaning derives from it. But here, there's no machine yet, right? And we already have a type thing. So we're just defining things like not in terms of a runtime. We're not defining our abstractions in terms of a machine. So we're abstracting away from the machine. So the object assumes that there's a memory cell that you can then change and update, right? Which is the RAM, right? But objects take advantage of that, and it models itself in terms of the fact that it knows that the RAM provides like memory cells that you can change. And so objects have attributes, right, that you can change. And it takes advantage of the fact that this is an actual action that happens in the real world, and then it uses methods to represent these actions, right? But they are real actions. And so the abstractions are provided by this machinery, these abstractions, methods and objects, and the runtime that actually makes it happen, right? So the runtime needs to then execute these actions, because remember, your program, if it's object-oriented, it only has meaning when it executes. And nothing can be inferred from it at drawing time. Why? Because I mean, the only thing that can be inferred is what you're looking at. So if something happened in the real world, all you can see is the last frame of it, the last update. So what things are now, you can only see now. But you cannot see what happened. And so in the same way is the code, right? In that it cannot be analyzed statically before the program runs. Why? Because there's this machine that will assign the meanings, the correct meanings. It'll interpret this program, and it'll assign the meanings to it, right? Even if it's compiled, never mind, right? But then the runtime actually needs to be running, so it cannot. The runtime is a thing that will be shipped with your program that you didn't code, and it's live, and it's actually running your program. It's running your program by causing these changes, right? It's causing these actions, and it's actually changing these things, and there you have your program. It's doing all of these, but you have modeled it exactly how to do it. You have modeled it exactly, right? So all our programs in the end will do this, but you have modeled it exactly in object orientation, because you're saying, well, yeah, there will be a place in the memory, and I have a method here, and this is how I'm going to change the place in the memory. right? So it's a one-to-one. Like you're doing exactly what will be done. You're doing exactly that, right? So it's not a abstract enough. But now we're saying that everything has in common the fact that they are a thing. Every one thing is a thing. So we take advantage of that. And now we have types. But I want another type. So thing is the beginning of dividing the world, right? So object orientation says that there are objects and methods, right? But now I'm saying that there are things and arrows, right? Or things in relationships, right? So we don't confuse arrows with actions. So if there are things in relationships, then I need some more water. Okay. So if there are things in relationships, I was saying, but I didn't think any further. So where was I? If there are things in relationships, then those are very general concepts, right? They're more general. So a relationship, in the same way that a thing can represent any one object, a relationship can represent any one method, any one action, any one message, right? Any one of them, right? But it just sits there and does nothing, so it doesn't need a runtime, because I am not actually doing things. So right now when I'm drawing, I draw a guy without a box, and then I give him a box. I change the drawing because the runtime is the program in this case, right? The runtime is this program that I'm using, Sketchbook Express, right? And I'm using this program, and it gives me a runtime where I can change the canvas by drawing on it. So that's what it allows me to do. But when I draw it this way, the drawings stay, and I don't change them. If I draw them by copying, like I was doing before, then I am using the runtime in a different way. So I'm not using it to the full advantage, right? Why? Because I'm not drawing on top, right? Because that's what it allows you to do. It allows you to change your drawing. But instead, I am restricting myself by copying it. So because I want the advantage of seeing all the steps that I took to draw something. And so that's something that I'm choosing to do because it's more important to me to see the steps than to actually draw something. And so I do it this way. That's why we're doing it this way. And so these are related in the same way. And now we have the thing type, and it has everything on it. Now, some things are round, like what other thing is round? Like a cue ball for like a pool, right? What's another thing that is round? It's not a ball. A round thing. Well, a planet. A planet is round. It's not a ball. Okay, let's not use a pebble. A pebble is round. Okay, so a pebble, a beach ball, and so this is a pebble now. So a pebble, a beach ball, and a planet. Now these things are similar. They share some traits, right? So if they're all round, we can say that they all have a radius, right? Or they have a diameter, right? One or the other. But we can say that they can be measured in this way. So that's one thing that these share in common. And so that's we can assign we can make another type if it's useful to us, right? So more than a thing. So the thing is one type. But I want to make it more general even. So I want type now. Because a thing, really, that's what it assumes. So the pebble assumes type elephant, and this, or I mean, when you were using 3 pebbles to represent different animals, the pebble was of type animal, right? And you were telling a story of different animals that you saw, and then you used the pebbles to be the animals, right? Because you were talking about what was important in this story was like how they moved, right, and how they got painted. And so it's not important which one is which, because you know the other ones didn't even move, right, in the story that I told you. So that's why I went with the category animal. So I said, okay, so my thing is going to assume the type animal, right? It's going to assume the type animal. So it's going to stand. It's a stand-in for animal. So there's an animal here, and an animal here, right? So I think when I say a thing, is that what I mean is a type, right? So thing is the most generic type. That's why I started with thing. So I wanted to start concrete. I didn't want to start with type, right? But a thing, now you see why it stands in for anything. Because if you ask for one thing, you could get anything. You could get a pebble, you could get a planet, you could get a dice, right? Or the pyramids. But now I'm saying that the more important concepts here, because we all understand thing, right? But it's not useful because everything is a thing, so it's too general. And the way that we're going to start to make it less general is by focusing not on this one type thing, but focusing on types themselves. So thing is one type. It just turns out that everything is of type thing, right? So everything is a type of something. But now I don't want to talk about the type thing. I want to talk about types themselves. So the things that I am actually drawing around to mean like a set or a group. So those are the things that we're going to talk about. Types. Types are important. So for instance, there's a type called round things, right? That's a type of thing. Like a planet. A planet is of type round thing, right? And the beach ball is of type round thing. This should be a colon. A beach ball is also type round thing. And we could go further and further and have a type called planet, right? I'm not going to do all of this. I'm not pretending that you're stupid, right? So we could have like a type planets with rings, or planets without rings. And we could have a type pebbles smaller than 3 centimeters. We could have a type colorful beach balls. We could have a type D20 for different dice, right? A dice of 20 sides. And we could have a type, I don't know what to do with this, but whatever. So we could go, deeper and deeper into the thing type, which I'm considering here to be like the master type, right? And does it contain itself? That's why types are types and not sets. If you read about it, that's the problem that it's trying to solve. So we're not going to go into that. Not important here. But so we have different types now. You can say that something is a type planet or type pebble, right? So you have all these different types, and that's what we're going to use. Types and relationships. So let's talk about types and relationships. But this video is too long, so we're going to talk about types and relationships in the next video. So we're going to talk about types and relationships in the next video.